In this lesson, we're just going to introduce the concept of vectors. So vectors is one that a lot of people usually come into the course with a lot of knowledge around this, especially if you've taken physics or uh, or science before. You might have talked about vectors. So just as a definition, our definition of a vector is a quantity with both magnitude or a size and a direction. We contrast that with the idea of what we call a scalar. So a scalar doesn't have direction. So a scalar only has magnitude. Okay, so these you could think of like just regular numbers. So I was just talking about a regular number. I'd be talking about a scalar. So like just like a real number, five. That doesn't have direction. It's just a number. Um, Now, it's when we're looking at physical quantities, so things you can measure, where we're going to want to make the distinction, and sometimes just looking at some examples and categorizing things into vectors or scalars helps to kind of get to this idea of like what a scalar and what a vector is. So think about some things that you can measure. Common first example to kind of distinguish between what a vector and a scalar are is for a vector, we'll often talk about velocity and spelled that wrong. And the scalar kind of comparable would be speed. So when you talk about how fast something's going, just in terms of pure speed, that's a scalar. But when we're talking about the velocity of something, we're talking about two things. We're talking about how fast it's going and which direction it's going. So this one, again, it can be a little bit tricky because from a non-scientific point of view, sometimes when people say velocity, they kind of mean speed and they're not talking about direction. But technically, if you saw a car driving down the street and you said it's going 25 kilometers per hour, you'd be describing its speed. If you said it's going 25 kilometers per hour north, then you'd be describing its velocity because you're talking about the speed or the magnitude and the direction. Another one you can talk about is displacement, which is a vector, and distance, which is a scalar. So they both kind of have similar ideas in that you're measuring how far something's gone, but when you're talking about displacement, you're talking about not only how far something's gone, but sort of in what direction. So it's kind of similar to the velocity and speed examples. If you said you walked 10 kilometers, you'd be describing the distance that you walked. If you said you walked 10 kilometers, south, then you're talking about displacement. Now, the direction doesn't only have to be given in terms of cardinal directions, north, south, west, east. It could just be relative to some position. Um, I walked 5 kilometers away from school towards somewhere. Well, then you're giving a direction, so now that's a displacement. Another common one, and this one can be tricky, is weight, which is a vector, and mass, which is a scalar. So this one's tricky because we often think about them both. A lot of times, if you're not thinking about a scientific or mathematic point of view, people will use these two terms interchangeable, just kind of in everyday use. Um, what mass means is how much matter is in an object. So, um, you might say yourself, maybe you weigh, I don't know, 40 kilograms. So that would not be very heavy, but let's say a person weighed 40 kilograms. That would be their mass. Although when people ask how much do you weigh, they'd often give an answer in terms of kilograms. But technically or scientifically, that's not what weight means. Weight is the measure of the force of gravity acting on the object. So there is a direction in that case. The direction is depending where you are. If you're standing on the Earth, then the direction is down towards the center of the Earth because gravity is pulling you towards the Earth. So that's giving you direction. If you were on the Moon, then your weight would be different because the force of gravity would be less, so a smaller number. So the magnitude would be smaller, and the direction would be, towards the center of the Moon rather than towards the center of the Earth. So that's the difference between weight and mass. So there's a lot of other examples. So you'll look at some in the questions that I'll assign, and you'll try to distinguish, what is a vector, what is a scalar. Okay. So I'm going to give you a few definitions here. So I'm going to pause the video and just write it down so don't take up too much time writing. Okay, so it's not definition, but the way we represent a vector is usually with what we call a directed line segment, or in other words, an arrow. So this arrow here represents the vector that we'll call AB. So it starts at A and goes towards B. So the magnitude is represented by the length of the vector. So the bigger the arrow, the greater the magnitude. And the direction is kind of where the arrow is pointing. So I'll just break that down. Okay, so that's kind of what we just said there. So there's two parts to a vector, both the magnitude and direction. So that's why an arrow is useful to represent it, because you can represent both things with that arrow. The length representing its magnitude, and the kind of direction or where the arrow is pointing representing the direction of the vector. Okay, so in this example, this vector which starts at point A and then goes to point B, we call that vector AB. So this is called vector AB. And the way you write it, so it's similar to the way you write a line segment. So we use capital letters A, B, but we're just going to put a arrow over top of the A and the B. So just like that. So that would be called, like if you ever see that notation, which you will, that's read vector AB. So meaning it's the vector which starts at A and goes to B. You could have a vector kind of going from B to A. So if it went kind of in the opposite direction, but was the same size, we'd call that one vector BA. So this is vector BA. So those two vectors are meant to be the same length, so meaning they have the same size, but they're going kind of in opposite directions. Two vectors which go in opposite directions are called opposite vectors. So vectors which have the same magnitude and go in opposite directions are called opposite vectors, which have the same magnitude. Are called opposite vectors. So that's a definition for you. Opposite vectors, same magnitude, but opposite direction. So the notation that we use for opposite vectors is we use a negative sign. So we would write, so A and B are opposite, so we would write AB is equal to the negative of BA. So the negative just means change the direction or opposite direction. Okay. Some more notation here. Notation for the magnitude of a vector. So the magnitude of AB of AB is written, and we put sort of vertical lines around AB. So it kind of looks like an absolute value of AB. So that notation just means we're only talking about the magnitude. So remember these opposite vectors, you could say that the magnitude of AB is equal to the magnitude of BA because they have equal magnitudes, so same length, but they're not equal. The vectors are not the same because they're in opposite directions. That brings me to another point, equal vectors. So what does it mean to be equal vectors? So equal vectors are vectors which have both things the same, both the magnitude and direction. Okay? So equal vectors have equal magnitude and equal direction. So for example, let's say we have vector AB, and then you drew a vector kind of beside it, which was the same, well, that's not going in the same direction though. Same length, and it should be in the same direction. So, but this one I'll call CD. So notice they're meant to be the same length. Maybe make that a little longer. Here I could say AB is equal to CD because it is the same length and the arrows are pointing in the exact same direction. And one last thing that I just want to talk about quickly in this video is I showed you how you can write a vector using two letters A and B. Sometimes we'll write a vector with just a single letter. So I'm not talking about kind of the beginning and end points, but I'm just going to call the vector using one letter. So I could use, usually in that case we use smaller letters or a lowercase letter. So a vector can be represented with a single letter. So usually V is kind of the standard one. Okay, but in the case where you do use a single letter, you still use that same arrow over the letter. And then you could talk about opposite vectors. So opposite to V would be just negative V. So negative V means same magnitude as V. So it would kind of be the same length as this arrow, but it would be going in the opposite direction. Okay, and then the magnitude of V, still denote it in the same way with those absolute value signs, or what looks like absolute value signs. Remember, that would be the same as the magnitude of negative V. Okay, so just slightly different notation where instead of using the two endpoint or the beginning and end point, you're just using one letter.